All right, so welcome back. We're going to keep working on NTP, AAA, and SNMP. Unfortunately, this is kind of going a bit long, so might need to just do a hard switch over after a while. But, oh, it looks like I already have this up, but in a different tab here. Perfect. Window. So, yep, this is going to be the fourth video on the topic, and I still have only covered NTP. I haven't even moved on to SNMP yet. So I think what I'm going to do in this video is just look up, it's just configure NTP authentication, and then move right on to SNMP. Even if there is more to cover in NTP, I just want to move quick, and I feel pretty confident during test day that I can just use the help and the question mark and kind of just figure it out, even though that's really not a very time efficient strategy, and time is definitely on the essence during test day. You get 6 hours, but a lot of people have told me that 6 hours, well, you used to get 8 hours, and I have heard that 8 hours is a little bit of a time crunch. It's hard to do it in 8 hours, and now there's only 6 hours. Okay, so moving on to NTP authentication. So let's just, let's keep the same strategy and try to use the built-in help to figure this out. So last video I did get NTP to work, so we'll just start off by verifying that again. So show NTP associations. Yep, so I've got an association here, and I wish I could get more information about that. Let's do help apropos NTP and see if we can get more information about the specifics of it. So we'll do pipe match beginning with the word help. So here we go. So let's look at the help reference. All right, so I don't see kind of what I'm looking for there. So let's do help topic. Now this, previously I did run through the whole, I did read this whole thing out loud in a previous video, and it did not have the information I wanted. Basically, I want to know what that BCST means, what the INIT means that I saw before. So here's some examples. Let's look at that. So I'm going to read this one. Example, configuring NTP as a single time source for router and switch clock synchronization. Debugging and troubleshooting are much easier when the timestamps in the log files of all the routers or switches are synchronized. Because events that span the network can be correlated with synchronous entries in multiple logs, we strongly recommend using the network time protocol, NTP, to synchronize the system clocks of routers, switches, and other network equipment. By default, NTP operates in an entirely unauthenticated manner. If a malicious attempt to influence the accuracy of a router or switch's clock with a wrong apostrophe succeeds, it could have negative effects on system logging, make troubleshooting and intrusion detection more difficult, and impede other management functions. The following sample configuration synchronizes all the routers or switches in the network to a single time source. We recommend using authentication to make sure that the NTP server is trusted. The boot server statement identifies the server from which the initial time of day and date is obtained when the router boots. The server statement identifies the NTP server used for periodic time synchronization. So that's what I have set up now. It's just periodic. If I were to reboot this, it would not have an initial time of day and date set by NTP. The authentication key statement specifies that an HMAC message, digest 5, MD5 scheme should be used to hash the key for key value for authentication, which prevents the router or switch from synchronizing with an attacker's host, posing as the time server. Okay, so let's set up that key again. And well, before we do that, let's see if there's better help for figuring out the specifics of it. It looks like, unfortunately, there's really not going to be help for that. So I can also do a match NTP. That narrows it down quite a bit. So there's examples. Let's take a look at this one. This is for client mode. Okay, so yeah, so it looks like so let's go to router 1 and let's set up that client mode NTP. So, oops. Detach. Perfect. Hopefully, yep, I do got my CLI there. So let's do a help topic on there, and then we can see the configuration. So configure private, edit system NTP, show pipe display set relative. So all we've got now is a peer. Let's do server. Let's just do the authentication they have there, but set up a custom authentication key. So authentication, set authentication key, and now we got to give it a number. So with 1, and then the type. All we've got is MD5. Don't have any more types. Now the value, just call it clouds again. Okay, now we got to set the boot server. Set the server. Okay, so this trusted key is kind of good to know because you're setting up the key here, but you're not telling it to use the key until you say that the key is trusted. Okay, so this is everything they had over there. Let's commit it, and hopefully we'll get NTP on this router. I'm not sure if I can just reach out to the other router to get NTP. Looks like I do have my syslog messages enabled for NTP, which is good. So we've got auth set up here. Oh, server is unreachable. So yep, there's no NTP server on here. If I take a look at the NTP settings, oops. We can see that this is not set up as a server. Okay, so let's set up authentication key information here as well, and maybe set up a peer. I guess I'm not sure how to propagate the NTP information to the rest of my network now that I've got it set up here, because you can see I do have it. I do have an NTP association here that it seems to be working, and then I have this association here, and I'm not sure what this BCST. Okay, so ref ID, reference ID. So it looks like whatever this means, it's a problem because it's not able to get a proper ID here. So I can just remove that. All right, and now let's see if I can figure out how to get NTP information to propagate throughout the network. So I'm going to go back to here. So this looks interesting. This looks interesting. So let's look at this. So when you are using NTP, you can configure the local router or switch to listen for broadcast messages on the local network to discover other servers on the same network by including the broadcast client statement at the edit system NTP hierarchy level. When the router or switch detects a broadcast message for the first time, it measures the nominal network delay using a brief client-server exchange with the remote server. It then enters broadcast client mode, in which it listens for and synchronizes two succeeding broadcast messages. To avoid accidental or malicious disruption in this mode, both the local and remote systems must use authentication and the same trusted key and key identifier. Okay, so let's start by setting that up. So this is interesting because I wonder if that's necessary. I wonder if I can just do trusted key 1 and then I can do delete server key 1. I wonder if this is possible, and then where I was having this init message or this auth message before, I wonder if that will change. So let's take a look at that. So we've got these auth messages because obviously the authentication is only set up on the one side, not the other side. So let's take a look at this. Now hopefully that allows it to successfully authenticate. But I wonder if I need to designate this as a peer. But that kind of wouldn't make sense to me because if I had to do that, that would just seems like a lot of configuration. but this is probably where that broadcast client and broadcast server relationship would save you from that. So okay, so when you use NTP, configure the router or switch to operate in one of the following modes. So this is, I think, where I can propagate it to the network. I have to choose between client mode, symmetric active mode, broadcast mode, or server mode. The following topics describe how to configure each mode of these modes of operation. And it doesn't tell you the difference between the modes, unfortunately. Let's see if we can get that in a different area. So nope, that's the first mention of any of those modes. So maybe we can go right to the RFC and take a look at some of these modes. Okay, so we do have explanations of these different kinds of modes. But I will skip that for now and go back to router 1, still in auth mode. I can see NTP server is unreachable for some reason. Okay. Oh, that's the wrong. So I'm pointing that to myself. I'm getting confused because I did the IP addressing in a confusing way. Because this is router 2, but it's actually got the IP1, which is not the most intuitive. All right, so hopefully we'll get some syslog messages, says things are a little bit better now. And we might see it go out of auth mode on router 1. So kernel time sync disabled, got a time reset, synchronized to the public IP where we actually are getting, it looks like it changed by 19 seconds. That's quite a big change. But it's still in auth mode, so it's still not propagating through to the other router. All right, but this overview looks like it will be good. Network time protocol, NTP, is a widely used protocol used to synchronize the clocks of routers and other hardware devices on the internet. Primary NTP servers are synchronized to a reference clock directly traceable to Coordinated Universal Time, UTC. Reference clocks include GPS receivers and telephone modem services. NTP accuracy expectations depend on the environment application requirements. However, NTP can generally maintain time to within tens of milliseconds over the public internet. Seems good enough to me. That's the method I'm using. I'm using a public internet server. NTP is defined in the RFC 5905 Network Time Protocol version 4, protocol and algorithm specification. Devices running Junos OS can be configured to act as an NTP client, a secondary NTP server, or a primary NTP server. These variations are as follows. Primary NTP server. Primary NTP servers are synchronized to a reference clock that is directly traceable to UTC. These servers then redistribute this time data downstream to other secondary NTP servers and NTP clients. Perfect. Okay, so here router 2 is my primary NTP server. So let's clear off router 1. Oops. There we go. Clear it off. So edit system NTP show pipe display set relative. So all this I want to go away. And then let's go to router 2 and just do the bare configuration for it to be configured as the primary NTP server. So in as far as I know, it's just everything we got here, but we're not going to have this command here. All right, so everything's good to go. Secondary NTP server. Secondary NTP servers are synchronized to a primary or secondary NTP server. These servers then redistribute this data downstream to other secondary NTP servers or NTP clients. NTP clients are synchronized to a primary or secondary NTP server. Clients do not redistribute this time data to other devices. So I want R2 to be my primary server, and I want R1 to be my client. Note the SNMP Subnet includes a number of widely accessible public primary time servers that can be used as a network's primary NTP server. Juniper Networks strongly recommends that you authenticate any primary servers you use. So these primary servers, they suggest you authenticate to the reference of the clock, but here it sounds like they don't have to be authenticated. So, so let me bring up Paint and explain this I think hopefully more clearly. So, and I'll use the term parent and child. So here we've got a parent, here we've got childs, more here, let's go down there. And let's say that they're all connected like this. So this is connected to this is connected to this. Now this is connected down here, this is connected down here. Like that, like that, like that. So the question is, which of these nodes has to be a client and which ones have to be a server? And from what I saw in the documentation, servers are going to propagate the NTP information down. So if I made any one of these a client, everything down here would be not have NTP. So I have to make, of course, this one a server, and I have to make these a server as well. They can be secondary servers, but they do have to be servers. They cannot be clients. So from here, same deal. This has to be a server, otherwise these will be cut off. And then these have to be clients. Sorry, and these can be clients. I think they can also be servers, but then you'll get extra traffic, control traffic, which you won't need. I'm actually not sure what disadvantage there is to making something a server when in fact the device role it is in would mean that it would usually be a client. I don't know what the disadvantage of that is. I know that there is a disadvantage in making it a client when it needs to be in a server, and that disadvantage is you would be cutting off those NTP messages from propagating throughout the rest of your network. But the other way, I don't know. I'm hoping to find out maybe. Each device on your network can be configured to run in one or more of the following NTP modes. Broadcast mode, one or more devices is set up to transmit time information to a specified broadcast or multicast address. Other devices listen for time sync packets on these addresses. This mode is less accurate than the client-server mode. Client-server mode, devices are organized hierarchically across the network in client-server relationships. I want to see if I can say this better. Hierarchically, is that right?
Hierarchical.
Oh, well, they're not. Oh. It's not giving me. Well, here we go. It won't give me pronounce. Here we go.
Hierarchically.
Hierarchically?
It's really into art.
Okay, well, whatever. I think I'm fine the way I am. Mr. Rogers approves. Symmetric active peer mode. 2 or more devices are configured as NTP server peers to provide redundancy. By default, if an NTP client time drifts so that the difference in time from the NTP server exceeds 128 milliseconds, the NTP client is automatically stepped back into synchronization. Okay, so that looks like another difference. The NTP client will still synchronize with the server even if the offset between the NTP client and server exceeds the 1,000 second threshold. You can manually request that a device synchronize with an NTP server by using the setDateNTP operational command on the router. On devices running Junos OS that have dual routing engines, the backup routing engine synchronizes directly with the master routing engine. So here's some more information. All Juniper platforms that run Junos OS support the leap second adjustment. By default, if the NTP server is aware of the leap second calculations, then the Junos device will automatically add the 1 second delay. PTP, Precision Time Protocol, is used to detect and propagate leap second configuration changes throughout all nodes in a network. So now that I've got the basic config, I am going to have a Wireshark Capture going. It is my guess right now, or let's say, I would be surprised if I didn't see NTP packets, but I wouldn't be all that surprised. And it looks like I'm not seeing them, so I am a little bit surprised. So let's try to figure out. So I think it's pretty clear that because of that, there is some configuration missing that would have those packets be sent. So let's see what options I have. So, yep, so let's set the broadcast parameters. Oh, now I've got to set a broadcast or multicast address to use. I mean, now this is where I guess I'm not sure what they want. So will I see packets with that destination address being sent out is the question I want to know. But before that, of course, the question I need to ask is, can I capture packets, or is it doing the debug? Oh, so yep, it's capturing. So that wasn't enough to send NTP packets out down the wire. Let's see what happens if I use the broadcast address of the subnet that is connecting router 1 and router 2. Okay, so we're still not getting any NTP packets being set around the link. I'll do another check, make sure that I'm still capturing. Yep, so that's just fine, but yep, still no NTP packets. All right, so let's just keep learning. NTP is required for common criteria compliance. For more information on the common criteria certification, see public sector certification. So we read about that in last video. Definitely a big part of network security. If you want to know what your network needs to be capable of in order for it to be secure, well, it's got to be capable of everything specified in the common criteria. So NTP, it's got to have, it has to be incapable of certain things. FTP, TFTP, Telnet, in order for it to be compliant with common criteria, which is a specification for internet security, you have to have particular configuration. I actually don't see common criteria anywhere here. Okay, so it's kind of interesting. I don't see where they have that listed here, and I also don't see anything for service provider, only for, well, let's service provider core, service provider edge. So these actually look really, really good. I'm gonna, yeah, look at this. So, here's validated solutions for service provider core, and here's validated solutions for service provider edge. This is all gonna look really familiar to me because my professional experience has been mostly concerned with the edge. I did, when I first started, have access to the core and was able to look at the design of the core. Okay, so here's the core, and here's the edge, and then here's the NTP RFC, so I'll include that in my description of the video, and then I will continue reading this, which of course I'll include there as well. This has been a pretty valuable resource, and I think this has been pretty good too, because it tells you the modes. Yep, it tells you how to configure them to operate in each mode. So I'll include that as well. I don't think I'll need this. Yeah, won't need this. So these are going to be my resources for NTP. Once I'm done with these resources, I'll be moving on to SNMP. In Junos operating system release 11.2 or later, NTP supports IPv4 VPN routing and forwarding VRF requests. It's going to be important to know. This enables an NTP server running on a provider edge PE router to respond to NTP requests from a customer edge CE router. As a result, a PE router can process any NTP request packet coming from different routing interfaces. Yep, and then we've got IPv6 VRF requests starting in Junos release 18.2. So I think that's might be what I'm on. Let's see here. No, I'm on 17. So I can have spaces in mine. There must be no space in the password for configuring the authentication key. I can have spaces in mine because mine's older, but on the test where it's using 19, I won't be able to use a space. Not that I planned to. I'm sure they'll tell you the password to use, or I mean, if I need to make one up, I'll just use like clouds or something really easy. Okay, so that was it. So let's close that and then go ahead with the configuration of so let's set it to operate in client mode. So we need the server address, we need the authentication key. Well, let's look at how to make it operate in server mode. In server mode, the router or switch acts as an NTP server for clients when the clients are configured appropriately. The only prerequisite for server mode is that the router or switch must be receiving time from another NTP peer or server. No other configuration is necessary on the router or switch. So the only prerequisite for server mode is that the router or switch must be receiving time from another NTP peer or server. So I don't think I intended to have router 2 set up in server mode, but I think I just kind of winged it, and I actually don't have it set up in server mode right now. So I'm going to be fixing that. So right now I've just got authentication, and I'm pointing it to a server, and I've got trusted key. So if I wanted to put it in server mode, to configure the local router or switch to operate as an NTP server, include the following statements. So I've got the authentication key, I've got the server address, and I've got the trusted key. Okay, so that is probably all I need. Specify the address of the system acting as the time server. You must specify an address, not a hostname. To specify an authentication key in all messages sent to the time server, include the key option. Okay, so I don't think I can have this actually, because this server here, just on the public internet, I don't think has a key. So I'm going to get rid of that. Oops. Okay, so now we've got really basic stripped down config. We don't have authentication to just this public server. I'll look at this again. I'll include it in the notes. So access is not allowed. Direct IP access is not allowed because it's an NTP server that doesn't have any web traffic to it. If I did an nmap on it though, which I don't have access to right now, I will see that port 123, I think, is the port for NTP is open. And in fact, what I can do is do a top exit, show system sessions. Oh, show system services. Or what is it? Show system. I thought it was sessions, but now this is UDP as well. So Now we've got it showing up as NTP clock. So really good stuff. Now, so I'm kind of not sure how I did that, but I think it would go back to local time if I deleted the configuration. So maybe it was at that because I had, let's see here, system NTP, delete, yes. Okay, so now it's back to local clock because I deleted that. So back one, I'm gonna quit, and so I think it maybe just takes a while for it to switch over. So yeah, I guess I'm not sure how that works because it's not going back to NTP. So I'm not sure how it went to NTP. I do know how it goes to the local clock, of course, because I deleted NTP. But what if I do a set date NTP? So it's still set to local clock, even though I did that. So yeah, I'm not sure how it switched over to NTP. Kind of unfortunate that I think it's where the Google search. It's just kind of interesting. Well, I don't see anything for local clock specifically. So yeah, I guess I'm not sure what's going on there, why it is still set to local clock. There's definitely a gap in my knowledge, unfortunately, that could be exploited during this test, and I could lose some points due to not knowing why it's stuck on the local clock and not switching over to the NTP server. It might just take a while for it to do that, but yeah, I'm just trying to see if there's like a time that it takes to switch over to NTP from the local clock. But I don't see anything just quick offhand. So I'm just going to keep this running. Hopefully it just switches over. Maybe it takes a minute or a few minutes or something. And I'll just keep working through these materials. So yep, so this is to configure it to operate in server mode. Yep, so yep, so I did all that. Don't have an authentication key or anything because that public server does not require authentication. So okay, so let's use, okay, now let's use the documentation to set it to client mode, and we'll be setting up that other address. Okay, so it looks like the big difference between server mode and client mode is just simply where you point the IP in your server statement. So if we wanted it to be in client mode, we would point it to a bogon IP used for management in our local network. But if we want to set it to server mode, we're going to use this is also a bogon IP, but we're going to use perhaps a IP in our server farm or a public NTP server. Probably not that, probably a private password protected NTP server in the server farm, which I can simulate because I've got, instead of just reaching out to the cloud here, I can create a new template, and I think I can get an NTP server. Well, what I can do is install one. Well, I mean, it's got to hook up to all the stuff, right? What is this? NTP? All right, well, I think I'm fine reaching out to that public one for now. I do remember learning about NTP all the way back to networking school, learning about stratums, learning about all the dirty details, but unfortunately, I'm having trouble finding that just using the documentation here. So, and that was a long time ago, so it's really not that fresh in my mind. But let's configure this in client mode, and we're going to do that just simply by pointing it towards a server instead of towards an actual NTP server. And then we'll leave off authentication for now. Okay, so now we've got an association. It's to that server, and then the ID is going to go from that public one. So still local clock. I'm probably still local clock on the other one as well. Yeah, so I'm not sure what is going on with that. Another thing we can see, I've got it set to UTC, but I can switch it over to my current time by giving it my time zone. So, yep, time zone America, Chicago. That's the time zone I'm in, Central. All right, so now hopefully that will look a little bit better. Yep, so it's 9:51 this morning. Still says time source local clock, but we will skip that and move on for now. So this is going to be done. Before moving on, I'd like to see if there's anything in these design center guides talking about NTP. I don't see anything. There's Nope, nothing there. Let's see if there's anything in the Edge guide. Okay, so yeah, this looks like more specific information. It's not talking about more of the general configuration settings you'll need on your network, like NTP, your management network, maybe some policer settings, especially for your management network. So that, and we'll see this when we move on to SNMP, that your management network can eat up all of your bandwidth unless you police it properly. So all the dirty details of SNMP are going to be, of course, in the SNMP, or sorry, of NTP, are of course going to be in the NTP RFC. So if I wanted to get really in depth, I could read this, and I might want to do that actually. So I guess just for curiosity's sake, I want to read this kiss of death thing. If the stratum field is 0, which implies unspecified or invalid, and you can see we've got stratum 3 here, so show NTP status. Pipe match. Stratum. Okay, so we've got stratum 4. Let's take a look at what the stratum is on router 1. Stratum 4, it says right there. Stratum 5. I think what that means is whenever you give a time, you increment the stratum to say, hey, it didn't came from me, it came from somewhere else. And then you can see, based on the stratum level, how many essentially other places it came from. So if you're playing a game of telephone, and it's like, well, I don't know what the original thing that was said was, but I know that if it went through 1,000 people, it's probably not going to be very close to what the original thing was. So it's kind of a warning, say, hey, this is stratum 5, it's not stratum 3 or 2 or 1. There could be issues with its accuracy. I think that's what that means. I'll look it up here. So let's look at the first introduction of the word stratum in here. So loosely following the conventions established by the telephone industry, the level of each server in the hierarchy is defined by a stratum number. Primary servers are assigned stratum 1. Secondary servers at each lower level are assigned stratum numbers 1 greater than the preceding level. As the stratum number increases, its accuracy degrades depending on the particular network path and system clock stability. Mean errors measured by synchronization distances increase approximately in proportion to stratum numbers and measured round trip delay. So I was right about the meaning of that. As a standard practice, timing network topology should be organized to avoid timing loops and minimize the synchronization distance. In NTP, the subnet topology is determined using a variant of the Bellman-Ford distributed routing algorithm, which computes the shortest path spanning tree rooted on the primary servers. As a result of this design, the algorithm automatically reorganizes the subnet so as to produce the most accurate and reliable time, even when there are failures in the timing network. Okay, but I think that's enough for NTP. I'm kind of tempted to dive farther into the dirty details of the RFC. It looks like it's really not even that long, but I want to, oops. But I want to move on, make sure I'm not running out of time for other topics. Yeah, it's still on local clock, so that's kind of driving me insane, but I wonder if I get rid of the time zone settings, it will switch over to NTP, although I did have the time zone set up before. No, because I wondered, like, oh, because it's altering the time based on some local settings, maybe it was sourced from the local clock, or at least it would show up that way. But that is not the case. All right, so yeah, I'm going to say that this is it for the SNMP part, or sorry, for the NTP part of studying for this test. I can go back later. I've got everything good to go there. So I'm going to go into another video, video 5, and I'll be working on SNMP there. So in my video 5, I'll be, let's see here, in the title for the video, I'll put a strike through here so it makes it more clear. And then I'll just end this video for now. This is the wrap up of NTP. So join me in the next video for SNMP. Thanks for watching.